Hello everyone, my name is SN Patil. In this video lecture, we will discuss gamma function and properties with example of gamma function. Let us see what is gamma function. Gamma function is a definite integral 0 to infinity integration e to the power minus x, x to the power n minus 1 dx is called gamma function. It is denoted by the symbol, and we read this symbol as a gamma n, that is gamma n is equal to. Okay, so here we discuss the property that is known as reduction formula property. The property is, this is the property number 2. In the last video lecture, we discussed gamma of 1 is equal to 1. Now, right now here, the gamma of n plus 1 is equal to n into gamma n. Okay. Now, let us prove this property. Now, we have the result. Gamma n is equal to integration 0 to infinity e to the power minus x, x to the power n minus 1 with respect to x. Okay. Now in equation 1, we replace n by n plus 1. Now it can be written as 1. It can be written as gamma n plus 1 is equal to 0 to infinity e to the power minus x, x to the power n. Put n equal to n plus 1 minus 1 cancel. In most of the numerical problem, we use this result, gamma of n plus 1. Okay. Now in right hand side, we apply the by parts rule here. Okay. That is x raised to n as it is. The integration of e to the power minus x, again derivative of minus x is minus 1 minus the derivative of x raised to n is n, x to the n minus 1, and this same integral, that is e to the power minus x divided by minus 1 dx. Now here put upper limit. When we put upper limit and n is a positive, then upper limit is 0. See, limit x raised to n divided by e to the power x, x tends to infinity, and n is strictly greater than 0, then its value is 0. Minus lower limit, put x equal to 0, so here lower limit is 0. Okay, now in second term, minus sign and this minus plus, n is constant, 0 to infinity, e to the power minus x, x to the power n minus 1 dx. Now from 1, this is what? Gamma n plus 1 is equal to gamma n plus 1 is equal to this n, and from 1, this is gamma n. In this way, we prove the property. Now here we prove the some additional result also. See, if n is positive integer, if this n is positive integer, if n is positive integer, okay, then gamma n plus 1, it can be written as n into n minus 1, gamma of n minus 1. We know the gamma n is n minus 1 into gamma of n minus 1. Okay. Now n minus 1, similarly we apply rule here. It can be written as n minus 2, gamma of n minus 2. Continuing in this way, n minus 1, n minus 2, n minus 3, dot, then here 3, 2, and here we get 1. And we know gamma of 1 is equal to 1. That is n minus 1, n minus 2, n minus 3, 3 into 2 into 1. And this is nothing but what? N factor. Okay. So here we get the two results. The gamma n plus 1 is equal to, see, I am writing in this way, is equal to so we have the two results. The first is n into gamma n when n is general. This is in general result. And second, we just prove if n is positive integer, then n factorial. If n is positive integer. Okay. Now here, suppose this is equation 2. From equation 2, we can prove gamma of 0. See, from equation 2, we can write gamma of n is equal to, the n is divided here, gamma n plus 1 divided by n. Now substitute n equal to 0. That is gamma of 0 is equal to, now here put 0, 0, gamma 1 divided by 0, 1 up, and gamma 1 is 1. So here we get the infinity. That is gamma of 0 is equal to infinity. Okay. Now let us discuss some particular example on this property. Gamma of, see, if n is positive integer, then gamma of n plus 1 is n factorial. If you put n is equal to any particular value, positive value, suppose I am putting 5, that is gamma of 5 plus 1. Okay, that is the simplification is 6, means gamma of 6, it can be written as 5 plus 1, and by result, it can be written as 5 factorial. Now gamma of 8, it can be written as 7 plus 1. Okay, that is 7 factorial. Okay, if n is integer, if n is fractional, that is gamma, suppose gamma of 5 by 2. Now gamma of 5 by 2, we have the general result. If there is a n is not positive integer, then we write the result gamma of n plus 1 is n into gamma n. Now let us write this 5 by 2 as a n plus 1. So it can be written as 3 by 2 plus 1. So it can be written as 3 by 2 into gamma of 3 by 2. Write again gamma of 3 by 2 in the form of n plus 1 if possible. Okay, yes, it can be right in the form of n plus 1, that is 1 by 2 plus 1. So it can be written as 3 by 2 as it is, and 1 by 2 plus 1 is 1 by 2 gamma of 1 by 2. Okay, and we know the gamma of 1 by 2, see 3 by 2, 1 by 2, and gamma of 1 by 2 is under root 5. In the next video lecture, we will discuss how we get the gamma of 1 by 2 is root pi. Okay. Thank you. Thanks for watching the video.